Hello students, and welcome to the CompTIA Tech Plus exam course brought to you by Third Level Technology. I'm your instructor, Jim Herbie. In this episode, we're going to continue in Module 2 of the exam objectives by discussing the final section in the module 2.9, and we'll discuss small wireless networks. Let's begin. In the first part of this episode, we're going to discuss the different 802.11 wireless network standards, and then conclude by discussing the three most common frequency bands, 2.4, 5, and 6 gigahertz. When discussing 802.11 wireless networks, there are two different groupings of three. We have the older or the legacy standards, which are A, B, and G, and the newer modern standards, which are N, AC, and AX. The original standard was 802.11a. It operated in the 5 gigahertz frequency. It was very popular for your initial business wireless networks because of the reduced interference on the 5 gigahertz frequency. When looking at your different frequency bands, 2.4, 5, and 6, remember two rules. The higher the number of the frequency, the faster the data speed, but the lower the signal range. With 802.11a, we could reach a data throughput speed of 54 megabits per second. The other original standard that came out simultaneously was 802.11b. B operated in the 2.4 gigahertz frequency band. It offered a longer signal range, but a slower data throughput. 802.11b could reach a maximum data speed of 11 megabits per second. Both A and B were released in 1999. They're a little over 25 years old. There was an upgrade to 802.11b, and that is the G standard. 802.11g also operated in the same 2.4 gigahertz frequency, but it increased the maximum data throughput speed to 54 megabits per second. This allowed G to reach the same data throughput speed capability of A, and allowed for better integration in your older wireless networks. These three standards, A, B, and G, are all legacy and are very unusual to find in your business environments. The three that are considered the modern standards are N, AC, and AX. 802.11n, also sometimes called Wi-Fi 4, is the first dual band standard. N can operate on both the 2.4 and the 5 gigahertz frequency bands. 802.11n also introduced a new technology called MIMO, M-I-M-O. This stands for Multiple Input, Multiple Output. MIMO technology can take the available bandwidth on a frequency and allow multiple users to access the same data stream going in both directions. With 802.11n, this increased capacity could reach a maximum data throughput of 600 megabits per second. The next standard is Wi-Fi 5, or 802.11ac. AC operates exclusively in the 5 gigahertz frequency band. It is primarily implemented in your enterprise environments, expanded the capability of MIMO with multiple user MIMO, M-U-M-I-M-O, multiple user, multiple input, multiple output. This could increase the available channel bandwidth capability by allowing multiple users to access the same data stream going in both directions. You could reach a gigabit per second of almost 7. 802.11n and AC are backward compatible. We can use them with the older legacy standards, but will be limited by the capacity of the older infrastructure. The most recent 802.11 standard is AX, also defined as Wi-Fi 6. The Wi-Fi 6 refers to the newest frequency band that we use, the 6 gigahertz band. 802.11ax is the first tri-band or triple band standard. It can operate in all three of 2.4, 5, and 6 gigahertz frequencies. 802.11ax also uses the same multiple user MIMO technology and can allow for multiple device handling in each individual slice of a channel. 802.11ax can reach a data throughput speed of up to 9.6 gigabits per second. There are three common frequency bands that we have been mentioning throughout these standards: 2.4, 5, and 6 gigahertz. 2.4 gigahertz frequency offers the longest signal range. It has better capability to penetrate through obstacles and walls of a building. But it is more susceptible to interference. Some types of household or business devices such as Bluetooth connections, microwaves, and cordless phones can all provide interference on a 2.4 gigahertz frequency signal. Your 2.4 gigahertz was used in your older B and G standards and can be used in your modern N and AX standards. The 5 gigahertz frequency offers higher data throughput speeds and has more additional non-overlapping channels. Within the 2.4 gigahertz frequency, there are only 3 individual channels that do not overlap: 1, 6, and 11. Within the 5 gigahertz frequency, we have a much larger amount of available channels. And we can use a process called bonding, where we can combine the aggregate bandwidth available in connecting or adjacent channels to allow for a faster single connection. Your 5 gigahertz frequency is used in your A, N, AC, and AX standards. And the most recent frequency band is 6 gigahertz. We also refer to it as Wi-Fi 6 and Wi-Fi 6E, which is for enhanced. Your 6 gigahertz frequency will provide the highest data throughput potential, but the shortest signal range. It is popular to be installed in your data centers or college campuses and learning environments where you can have an extremely large amount of users within a centralized location. The 6 gigahertz frequency at the moment is implemented with the 802.11ax standard only. That will conclude our discussion of Section 2.9, Small Wireless Networks, as well as conclude Module 2, Infrastructure. In our next episode, we'll move on to Module 3, which covers Applications and Software, and discuss 3.1, Operating System Components. We thank you again for following along in the episodes and the course, and wish you best of luck in your studies. Enjoy the rest of your day.